Hello, my name's Nancy,
Hello, my name is Chris.
and we'll be doing a quick video where we introduce and explain the activity for the next concept that we'll be introducing to students. The next concept we're going to be exploring is equivalent graphs. And there's this quick introduction activity that we'll be doing with the students.
Yes, and I will go ahead and share my screen. Can you see my screen?
Yes.
Okay, so this is
Wait, before
basically,
you go, can you present so that it's like bigger for the
yes,
audience to
present.
see?
Waiting. There you go. Can you see
There we
it?
go. Yes.
Okay, so this is going to be the activity that we're going to be doing. And essentially, you're going to be given 4 graphs right here, as you can see. And actually, I can go to the next page. So you'll be giving 4 graphs, and you're gonna want to tell your student, or you're gonna want your students to essentially like figure out which one is the odd one out. So which graph is not equivalent when compared to the other 3. And typically this is gonna take like around 10 minutes or so. So you want to give like a good 3-4 minutes or so of just kind of like letting them talk it through or working on their own, and then like the other 5 minutes would be sharing and just kind of like working through with the activity to see if they understand it. And the thing about equivalent graph is that it's slightly different than if you were to just like look at points and lines. So let's say if you look at, so let's say if you look at, no, I can't. Oh, never mind. Back. Okay, I guess I'll just try to annotate if I can. It won't let me. There it is. Okay,
Did you want me to help you annotate?
I can annotate. I got it. Thank you.
Okay.
I think I just need to move like the task bar away because it's like in my way. Okay, I have it. So let's say like if you were to look at this point and you see 1, 2, 3, 4, 5, 6 points, and 1, 2, 3, 4 line or 5 lines, and then you look at here, it's like 1, 2, 3, 4, 5, 6 points, and then 1, 2, 3, 4, 5 lines. Some might say like, oh, this is equivalent because there's equal amount of points, equal amount of lines. However, that's not the case. Like we're not looking at just only the points in line. Um, when we're talking about equivalent graphs, we're essentially saying like that even the amount of neighbors is should be considered into the factorial of that. So let's say if we're looking at this point and this point, and then let me just change the lines. If you look at it from here, this point right here where the heart is has 1, 2, 3 neighbors. And then if you look at this point right here, it has 1, 2, 3 neighbors. So this point and this point would be considered equivalent. And then the same goes for, let's say, if you were to go to this point right here and this point right here. If you look at the amount of neighbors, 1, 2, 1, 2. So that means this point right here and this point right here are equivalent. So for this activity, essentially, when you're looking at the equivalent graphs, it means that every point has to have the same amount of neighbors as well as like when compared to like another point from another graph. So overall, you're trying to find out of these 4 graphs, which one has like, I guess like an off point or like a
Which
someone like a
structure
point.
is different?
Yeah, which structure is different. Okay, and then I'm just gonna go spoiler alert to, nope. All right, this is, why is it being weird?
Oh,
Nope. Nope.
well, it showed earlier
Oh, okay, okay.
from just a quick clip that
Right
you saw that the answer was B.
there it is.
There we go, that the answer is B. And this is so because I'm just gonna annotate because
Okay.
as Chris explained earlier with A and C already, so we could see that A and C are both equivalent because each of them, rightfully so, have equivalent in terms of points and points, lines, and neighbors. And same as D, if you can see that there's, we'll just use this point as an example, D in graph D, where there's, and C, where where there's also 3 neighbors, 1, 2, 3, 1, 2, and 3. And the solutions even color coded it too. And the one that is odd one out is B because there's there's one dot that has 4 neighbors, whereas everyone else at most has 3. So in this one, there's that dot with the heart, but there's, oh, that's not right. There's 1, 2, 3, 4 neighbors. So that's why that graph B is the odd one out.
Yep, and that will be the, let me just make sure, I believe. And then there's also a secondary part. If you have like time left over, you can also have students kind of draw their own graphs and then have 2 of them be equivalent and 1 of them not be equivalent. And then maybe have like a kind of like a challenge where like students are kind of saying like, or you can like keep track of points of like who gets like the most correctly and such. This is kind of like an extra, in case you have time left. But that will be the activity of equivalent graph for part 2.1. Thank you.
Bye, everyone.
Bye.